Specifically in DevOps, you're not just going to focus on one tool, as many of you might have heard in the introduction. And for those who missed introduction, I'm just trying to go through it again. So DevOps is actually a better way of doing things, which means whatever that you're doing, which could be part of development, which could be part of testing, which could be part of administration or operations, whatever that you're trying to do. DevOps is a culture which tries to put in best practices which can help us to get efficient and better output. Okay, so that the time and the cost, whatever that you're going to put into whatever task you're doing, is reduced. So, in that way, one of the important area where each individual that they face problem is virtualization. Okay, that is when we use tools like Docker. So to first understand Docker or what do we need, let us first understand what are the problems that people face. So now when you take a developer, or it might be a QA engineer, anyone who is working on the development side or the development community, so who are striving to get the product with better quality and get it released. So when these people are trying to work, everyone need their own machine, right? So regardless of what kind of engineer you're going to be, you need a machine. Now, why do you need a machine? You need a machine because you have certain tasks to do, and for that particular task, you need a specific architecture or a specific operating system, and then in that, you need some specific applications based on which you will be running. So now, for every user who is working in an organization or on a product, everyone needs a machine. That is the first point. And the second thing is, it is not possible for everyone to work on the same machine. So ideally, we need different machines. And again, all these machines are not going to be the same because say if a person from a development is doing some task, he needs a machine based on his requirement. And if a guy from QA is working, and again, he needs a different machine. And within the same team, say one guy is working on another product and the other guy is working on some other product. So even though within the same team, the requirement might be different. So everyone need different kind of machines. So what are the general problems that the user might face is if you go to one machine to another machine, you need the same set of files or libraries. In general, whatever dependencies that you have, everything should be there. So when I say different dependencies, these are nothing but the applications or in general some files or libraries from which you can run your application and service. Now all these things to be present in the machine. So now say if you're moving again from one machine to the other machine, you need to check and verify whether all these things are present or not. Okay, now in case if it is not there, then you have to do certain maintenance to get it done. That is one of the problem. The next one is portable environment. Portable environment means now it's not just about libraries. Say you had something put in a specific machine and you need to have the same environment on that machine also. For example, you had your machine, you had put all the content into a folder. Okay, now if you're trying to take the same thing to a new machine, you need to have the same directory as a small example so that you will have the exact environment there also. So it is not so possible to port in the sense if you are doing something in one machine, if you want to do the same thing on other machine, that is what we call it as port, wherein whatever that you did here you should be able to do there. So that is what in the technical term we call it as porting or portability. So portability means whatever that you did in one machine, you should be able to do it in same way on other machine. Okay, now for that, there are so many problems that you might face. Like I said, your account will not be there, you don't have libraries, you don't have the directory, or you don't have the environment. Say, suppose if one thing is on Windows and the other machine is on Unix, then things will not work. So, like that, there are so many problems which user faces. And not only that, as I said, the platform also depends. Now, if you ran some command in one operating system, the same command might not work on the other operating system. So for a user, if we see, the portability issues are huge, and because of that, it's not easy for anyone to replicate a task. So on today's release tasks that we do, we have to do so many replications and we need so many machines because of automation. So if you keep depending on one machine to do all the tasks, it will take a long time for us. So how can you do things better? You have so many machines with you. So rather than doing one task at one machine, you can use the same task to distribute across various machines and get it done faster. So that is how one of the way automation has been completely increased. So for all these things, a user has to spend so much of time if he is trying to do it manually, right? So a waiting period is long and there's too much of effort in recreating everything. So that is one of the biggest problem from the user. Now, if you see the same task, what are the problems that operation engineer or a system administrator who is maintaining the server is going to do? So for him to keep on requesting, like if every user requests a new machine and something new, then the cost is going to be very much high, wherein he's not going to pay, but they are going to maintain it, right? So cost and performance is the important thing, because if you keep on adding newer and newer machines, there's too much of things to buy, and at the same time if you have too many things, and it's not so easy to maintain, so maintenance also becomes a biggest problem. The next thing is, now if a developer or a QA guy wants to reproduce something and if some libraries are missing, the point of contact will be a system administrator. So they have to spend their time in making sure that the efficiency of whatever machine that you're working on should also be high. Because if you keep on updating something with newer and newer things, it's not going to happen. So you have to go with new machine again. All right. So even a system administrator goes through the same problem. So for every user he's asking to do something, there's a lot of maintenance tasks which the system administrator is also going to do. And now, for a couple of guys who have already gone through this process called continuous integration or deployment, which is nothing but a process through which we can release the products very fast to the customers. Now, when you're trying to do these kind of concepts like continuous integration, now how is that you can do things faster? Now again, for that you need lots and lots of machines and you need so many things to do. Now for all these things, if you look at the end, it is not possible to keep on purchasing newer machines or keep on having different machines for every requirement. Okay, so this is one of the generic problem what people would be facing. Now, to understand how can we overcome, DevOps has a solution, or in DevOps, we have a solution for this. So one of the standard solutions that we have is by using a container ship. Okay, so there's a specific concept called containers, using which you can use these containers to act as a operating system, which means rather than having a separate machine, you can have Docker, wherein Docker is going to act as a container. And in that container, you will have a specific operating system of whatever you want. But the difference is, it is not going to be a new machine, but within the same machine, you can create different Docker containers through which you can access different machines. That means now, if say you are having one machine and on that machine, if you are running two containers, so if a user wants to work, he can connect to these two containers and he can work as if he is working on two separate machines. Okay, so that's the advantage of Docker. So what exactly is Docker? If you understand, Docker is a platform. So when I say platform, it is a way where you can do all your development work, you can ship your code, and even if you want, you can run the complete a software or application, wherein it uses a technology called container based technology. So what exactly does all this means? Again, I said Docker is nothing but a replacement for your machine. So rather than going for a newer machine, you can use a Docker container through which you will work as if you're working on a new or a separate machine. Okay, so what exactly Docker does is it does a complete operating system level virtualization. That means for every machine, when you say, what does a machine contain? A machine contains two things. One is hardware, the other one is your operating system. So operating system does all the tasks and it uses the hardware to do this task. So what exactly Docker does is on a single machine on which you have installed Docker, it will use the same hardware and it will try to do some virtualization through which it will be creating multiple operating system based on your need. So now, for example, if you are using a machine which could be a Windows or say it could be a Red Hat machine. That is what your laptop or you are using that machine. And suppose if you wanted a Ubuntu machine, then rather than creating a new machine, what you can do is you can create a Docker container which contains a virtualization of Ubuntu. That means if you go inside that Docker container, you will be working as if you are working on a Ubuntu machine. So that is how it will be. Suppose if you want to work on CentOS, now rather than installing a separate machine, separate hardware, and on that you are installing separately CentOS operating system on your existing Windows or Red Hat machine, what you can do is you can bring one more Docker container, and in that Docker container you can put your CentOS operating system virtualization, so that instead of having separate machine, your own machine will have all this virtualization through which you can connect and work as if you are working on a separate machine. Okay, now when I'm talking about this, so where can you run a Docker? So when you want to run a Docker, you can run Docker regardless of what kind of machine that you're already working. So you could run Docker on a physical machine that you have, like on your laptop or on a specific server in the data center in your organization. If you want, you can run on that, or you can run Docker even on another virtualized machine. Okay, because we already have the concept of virtualization like VMware, right? Or OpenCloud, or pretty much there are many virtualizations which is available. Now, if you want, you can create a Docker container even inside another virtualized machine. So it is not mandatory that you should create it on a physical machine. You can even create it on a virtualized machine also. Or you can also do it on a cloud, which means now when you have systems like AWS or OpenStack, now you don't even have to have a machine. So there will be some machine which is available on the net for you to use. So if you want, you can run Docker containers even on that. So regardless of what kind of machine that you are using, you can run Docker. So what you're going to do, so you can run Docker anywhere and anything inside it. So if there is something that you can run on the machine on which you are working, then you can create a Docker container and you can run all those same tasks inside the Docker container. Now that means, now say for all this demonstration, I'm using a machine. So this is my laptop. Now I am going to create a Docker container here. Okay. Now say for example, the machine that I'm using is Windows. And now suppose if I install a Docker container in this, now I can install any kind of operating system on that by means. Now on my Windows, if I want a Red Hat machine, what I can do is I can create a Docker container which contains a Red Hat machine. So now, rather than me creating a separate machine or having a separate laptop for me to work on Red Hat, simply on the same machine, I can have one more container wherein that container acts as a complete machine, wherein it will be having a Red Hat operating system. Now, if there is something that I can do on my laptop, I can also do the same thing inside that Docker, wherein you will feel like you are working on a Red Hat machine. So that is the point that this says. So the host is nothing but the machine from where you are creating this Docker or running the Docker. So host means that base from which you are running the Docker container. So what and all can you run on a container? There is no restriction. If there is a command or some application that you can run on your host, then it can be run on the container also or on the Docker. Okay, and the other main reason why we are going with Docker is it is quite light in weight. By talking all those things, it doesn't mean that Docker is going to take a huge space or it is not going to take too much of resources on your machine. It is very, very light in weight. And that is the reason you can create as many containers that you want inside your machine and have a replication or the concept of replication. So, okay, now that's what I was talking about Docker. Now it might be still little confusing and what is this? Why do you need it? Okay, now think Docker in the terms of the containers what we were talking. So what exactly is a container and how it is going to work in general? Okay, so the example why they came up with the name called Docker, and especially if you're seeing this image, right? So why the image it came like this? So in general, if you're talking about containers, so containers are the ones which are being used for generally shipping products from one place to other place, right? So what do they do? So basically, in olden days, when they had a problem wherein they have to ship one, say you have some goods to be shipped from one place to another place. Now what they did is they had to dump everything in one place and they have to ship. And now on the same ship where you are sending some goods, you had certain other materials to do, and then you have to send that also. Now when they had too many things to send, then the problem was with the space, and you cannot just use one ship specifically for one product. There would be so many things. Okay, so that is when they came up with this concept called containers. So what does a container do? So if you had looked at in the movies and all those things, you can see huge boxes like this, right? So what exactly this box is going to do? So this box is going to act as a complete space wherein you put whatever that you want inside. And now say you have rice to be shared or rice to be shipped, and along with this, say you have some raw iron material also to be shipped. Now what you can do is you can use one container to put all the rice and the other container to put iron. Now how are you going to send both of them together? You can make it layer after layer. So like this, you can have as many containers as you want and put in whatever specific things that you want to put. And when you are sending it, that one ship, you can put different containers on top of it. Okay, so it's going to be layers to layers. So it is on the similar concept Docker also works. Okay, so what is the difference? That is, now when you say a Docker container, so what and all are the things the Docker container is going to have is basically the Docker container is going to run on any of your machine, right? So it could be your laptop, it could be some of your virtual machine or like a VMware, or it could be on a cloud. So there is some machine on which you will be running Docker, right? So what Docker will be doing is it will be running on top of your existing host operating system, correct? Now here it will be having layers and layers of applications and softwares wherein whatever that you want, you will put inside the Docker and you will start running. Say for example, I want some Java 1.6 to be run. Okay, now what I'll do is I will create one Docker container on my machine, and inside that Docker container, I will install Java 1.6. Okay, now I will start running. Now, whenever I want Java 1.6, I will go specifically inside this and I'll run. Now, it's not about running application, but I can put specifically whatever operating system I want. Say I want Red Hat machine, then I will put Red Hat in this. In the same way, I can create another container with the same Red Hat operating system, or I can use another operating system. And if I want, I can put Java 1.7 in it. So like that, you take it as a container and you keep on adding whatever that you want on top of the existing one. So it will be layer of layers. Okay, so that is how you can have the machine of a specific requirement. Rather than creating a new one on the existing machine, you can have a replication. So that is what containers is going to help you with. Okay, so now, all right, so I've been talking about Dockers and what is containers as in just an introduction. Now, for few of you, if you already aware of this concept called virtualization, or if you have heard of tools like VMware, then you might be little confused. What is the difference between Dockers and virtualization? Because both are one and the same. Because if you have heard of this software or tool called VMware, it does the same thing. That means if you install VMware on your machine, okay, say I install VMware on my laptop, then using the VMware, I can create many machines on the same machine. So it is going to be like a machine inside a machine. Now that is what even Docker is doing. But what is the complete difference of what is the virtualization concept versus what is this the containers concept that is going to do? In fact, containers or Docker is also going to do some level of virtualization, but it is not doing a complete virtualization like other tools that we are going to, or which we already have known. Now, if you can see this diagram or figure, the basic difference between virtualization using other tools like VMware and virtualization through containers or Docker is that if you see, for every new machine that you create on your VMware or other previous virtualization, the difference, if you see, it will have a complete set of operating system itself. That means now you will be having your machine, that the host machine, correct? So on that host machine, you will be having some operating system that you're running. So let's take example of my laptop here. So my laptop is a physical server. Okay, and I have an operating system running. So currently I have Windows 10 running on my machine. So this is what my host machine or my workstation on which I'm working. Okay, so now on top of this, what you will do is you will install some software for virtualization like VMware, Hyperversion, or whatever is related. So now using this, I will be creating some virtual machine. Now, when I'm creating a virtual machine, say what will happen is suppose if I need Red Hat. So if I create a Red Hat machine using this hypervisor tools, then what will happen is I will get the machine, but that machine will also contain a complete operating system. So it will have a separate operating system, and then based on that operating system, you will be having certain files or libraries, and then inside it, you will be installing whatever the applications you want. So like that, say if this is a Red Hat machine, then it will have its own operating system, libraries, and application running on it. Suppose if I want to create a CentOS machine, then I will create another virtual machine that will have a separate CentOS operating system, libraries, and application. Like this, every new machine that you create using this hypervisor or this virtualization concept, you will be having a new operating system and all the libraries dependent. But by doing this, what will happen is, if you look closely, by having a separate operating system, it is going to take too much of resources from this machine. That means to run each one of them, you need some specifications, right? If you are installing a new operating system, what and all things they will ask you? First thing they'll ask you is you need some space, and then they will say you need some RAM, right? So these two things are very important. So if you're buying a new laptop or if you're buying a new machine, this is what they will be asking. So what is the hard disk space you need, and then what is the RAM memory that you're going to need? So in the same way, if you are creating a new machine, then you are not buying something separately. This will occupy the existing operating systems or the existing machines resources. So for example, if I have 10 GB of space in my laptop, and say if I have 256 gig of RAM, just an example. Now, if I install a new Linux machine, and if that needs, say, 2 GB of space and some 120 GB or 256 GB of RAM, then it is going to use the same thing from my machine. Now, like this, for every new machine that you're creating, it is going to occupy that resource from your existing machine. So this way, we have a limitation of how many machines that we create here. It is because if your host is of a lower configuration, then you cannot have too many machines. So at the same time, if you want to have many machines, then the host has to be of a better resource. Only then you can accommodate more and more machines. So that is one of the problem, wherein for every machine that you create, you need to occupy all the resources from your host. Okay. And second thing, now, regardless of whether you are using it or not, if you create one machine or one virtual machine, now it will be keep on running it on the host. So when you say it is keep on running, it is going to occupy some resource, correct? Now, if you see my laptop, I'm not doing anything. I mean, literally, I'm showing you the classes and I'm working. But if you see internally, I'm not doing anything much into this, right? But still, it is going to occupy some resources, some memory, and it has to handle. In the same way, now, if you want all these new machines or virtual machines that you have created, so it should be keep on running even though you are not using anything inside it. But for all these things, it is going to occupy some memory and space from your original host. So this is the actual problem that we have using this virtualization concept. But the same thing now, if you look at containers, how different it is. So if you can look at this diagram, for every container that you create, you don't have a complete operating system. So what do you mean by that? It means rather than having a separate operating system for every container, the Docker is going to use the host's operating system itself to run whatever that it needs. Okay, so that is the advantage where whenever you want, you can bring up a container, and whenever you don't want, you can just stop. So that way, if you see, it is very light in weight and it is not going to take all the resources like this, because only when you have a new operating system, it needs a RAM and a space. But here, for the container, it is going to use the host's operating system itself. So with the existing resource itself, you can create as many things as you want. So it is quite light in weight and it is more powerful. So that is the reason why, if you see, the entire IT is moving towards containers or this new concept of virtualization. So now I can bring as many containers as I want, and I can start working everything on the host itself, so that it is quite efficient with whatever operating system and the resource I have. I can make use of it efficiently. So rather than creating separate operating system and working on that. Getting it? Any questions on this so far?
Sir, can you repeat it one more time, the Docker one, to explain about the host OS?
Okay. Now, as I said, if in the regular or in the older way of virtualization, that is like in VMware or Hyper-V, every new machine that you create, okay, inside your existing machine, now that will contain a separate operating system, okay, wherein because of having a separate operating system, now you need so much of resources like space and RAM to be occupied for each one of them. Whereas in Docker, it is not a complete operating system, but it is a container that we call. Wherein, what does a container going to contain? Container is going to contain only the libraries and files that you need, and whatever applications that you need, you will be putting inside it. And for this, where are you going to run? You are not going to run on a separate operating system like this VMs, but you are going to use the host operating system itself to run whatever that you need. So that is the advantage or difference in Docker. So you are not going to have separate operating system for each one of them. It is going to use the host operating system itself. Getting it? Yeah, Mohammed. Any questions? Hello.
Yeah, Adam, like, what is the difference between Vagrant, like, difference between Vagrant and Docker? Does Vagrant is same like the virtualization?
Yeah, it is again concept of visualization, but it is not like Docker. Now, Vagrant is just for environment. So again, Vagrant needs some specification like this. So Oracle has another virtualization like VMware. VMware is being owned by a different company. In the same way, Oracle has a specific application for virtualization. So the Vagrant is going to run inside that. Whereas Docker is you are going to create a complete operating system. Vagrant is not going to help you to create a new operating system. It is only for replicating the environment. Okay. But Docker means now on an existing machine, like I said, this is my Windows machine. What if I need a new Red Hat machine? I don't have to install a new one. I can use a Docker to create a new operating system, or I can create a container and work on that as if I'm working on a Red Hat machine. I don't have to have it separately. Whereas Vagrant is only for environment. Say you have some environment in the sense the libraries, applications, whatever that you have. If you want to have it on a different machine, it's just take this and put it over there. But it will not help you to create a new machine itself, whereas Docker does that.
Oh, okay. Thank you.
So if you try to understand now, why exactly do I need container? That's the next question that you will have. So one of the thing I said is, if you want to have different machines, now rather than having a complete operating system, which is going to take too much of resource, you can use Docker containers. And not only that, what you can do is you can replicate all the things easily. So what do you mean by replicating all the things easily? That is, now say if I am working on my laptop, I create a container which is based off Red Hat. Okay. Now I do something. Say for example, this is my container which contains the Red Hat information. So whenever I go to this container, it will be having the Red Hat image and I'll be running everything as if I'm running on a machine with Red Hat installed on it. Now on that, I will install say Java 1.5 and I will do something and I will do my task. Now, if I want to do the same thing on a different machine, then what I can do is I can simply take the same container, put in on some other machine, and I can start running it. So without any problem, if you see, you can port the data from one machine to another machine. Or now take example, if one of you want to do the same task that I am doing, now, how can I share what I've done with you? It is not quite possible, and you have to do everything from the beginning. Instead of that, I can give this container itself. Now, when I say I'm giving this container, I cannot give the same container, but I can give some concept of copying this container to you so that you can start your own container with the reference of the container that I've given. Now, using that concept, if you bring a container in your machine, you will be also accessing a Red Hat machine separately, but if you go inside the container, it will be the complete replication of what container that I am using. That means even you will have Java 1.5, and whatever that I had done in my container, you will also be getting it over there. So that is how you can actually reuse it and replicate. Now, this is the biggest advantage of why we are going to it, because if you go back to the very first slide that I was talking about, the user problem is they might use it on different machines, and porting is the biggest problem because the libraries or files, everything might be missing. But now if you are doing anything on one machine, you just take the container, a copy of that, and go to some other machine and start running. Everything, whatever you had here, you will also be having there. So now it might be a developer or it might be a QA, they can easily reproduce the environment, right? Now, if for some testing purpose, let's take QA, they are performing some performance testing. Now, they want to do a task 3 to 4 different ways so that they want to see how the performance is working. Now, the same environment has to be reproduced 3 4 times. Now, if you are setting up a new machine or they are setting up a virtual machine like this, then it is going to take too much of time wherein they have to install, make sure everything is available. But the same thing now, if I do it in one machine and create a replica of the same container differently, without no time, I will have 4 containers, which is exactly the same. And I can start running whatever I want, right? So that is why it's quite useful. So it is not only for testing, even we can use it for shipping the product to a customer. That's what the earlier slide that I was trying to show. So Docker is a platform wherein you can use it for developing or running application, and you can even ship it. So the major advantage why people started using Docker is from the DevOps perspective. If you see, it is easy for us by which you can create new machines within the same machine without any cost. And for the developer or for the QA community, if you see, it is easy for them to reproduce an environment without any problem of ensuring that missing dependencies or spending time to recreate everything. So from both the concepts, from the user also, it is quite easy to replicate environment. And from the administrator perspective, we are not spending too much of money and it's quite efficient because it is very lightweight. If you're going with a new VM, this is going to take too much of resource separately for this, and then for each host that you're creating, that will also have a separate one. But here there is not much of resource consumption and you're not spending too much of resource for any other things also. So that is why Docker is quite popular. Getting it?
Yeah, done.
Yes,
Mohammed,
yes, sir.
Tapasya, Himanshu, any questions?
Not yet, sir.
Till now, not any question.
Okay. Okay. Now, how exactly you're going to do all those things? Now, the next question comes is, okay, I was talking about Docker container, Docker image, and all those things, right? So how exactly a Docker container is going to work? So what exactly do we mean by this container? What is that it is going to contain? Okay, so now if you look a little deeper, for every container that you're creating, okay, so basically that will have certain layers and layers of some content. So what exactly it is? So if you have a container, okay, the first thing that container is going to contain is a Docker image. So what is that image? So that image is nothing but a file system layered over each other. That means now if you are creating a Docker container, okay, now the first thing that you need is what is the operating system image that you're going to have. So like I said, if on my machine Windows, if I install Docker and then I want to run a container based on Red Hat, so the container's base image is going to contain a file system layer. Okay, and now if you say, then what is the difference between virtualization and here? The difference is that we are not going to have a complete operating system of Red Hat in Docker container. So instead of that, it is going to contain only the base image. So when I say base image, the base file system and the bootfs. So bootfs is nothing but the image content using which you will be bringing up a operating system. So when you say operating system, there are many things that contains inside it. Okay, so in Docker, it is not going to have a complete operating system. So rather than that, it will have only the base file system, that is the bootfs. So that is what it is going to contain. So now if you say I want to create one container, the first thing that you need is you need what is the image based on which you want to create a container. So you need to decide, is it a Red Hat machine that you want, or is it a CentOS machine you want, or is it a Ubuntu that you want, or it is a Windows. So like that, whatever machine that you decide, with respect to that, you need to first have the image, the base image based on which the container is going to put. So as soon as for the Docker you say that I need a container, the very bottom layer of that container will contain the image. So that image will contain only the bootfs, which is nothing but the actual kernel on which you are going to run everything. So this bootfs or the base image is what will specify what is the operating system that you want inside it. So that means it is not a complete operating system, but from the operating system, only the bootfs is what you are going to have in this base image. So like this, for all specific operating system that you need, there will be a specific image based on Docker using which you will be doing. So now if you create a container, you have to tell the very first thing is what is the base image that you're going to need. So if you say you need Red Hat, then the base image will contain the bootfs of Red Hat. So if you want to work on Ubuntu machine, then the container base image will contain the bootfs of Ubuntu. So like that, the first or the bottommost layer of a container is going to contain a Docker image. That is what is going to help you to run a specific command based on what image that you are going to have. And remember once again, this base image or the bottommost layer is going to contain only the bootfs, not the entire thing of a operating system. That is why it is quite light in weight. Okay, so that is the first thing. And now if you see what exactly this image is going to contain is the bootfs. And the next thing is it is actually also going to contain a file system, because whenever you say you have a bootfs or a kernel, it needs a file system. file system is nothing but in an operating system where you can store something and you can write something. Basically, you need some files to be managed, right? For example, in your Windows, if you are having a hard disk of say 8 GB, okay, when you install the operating system, generally the administrator, whoever is installing, he will say that I will create C drive, and in the C drive I need at least 1 GB of space because it is going to take all the files specific to the operating system that you're installed, right? The program files. In the same way, even when you say you have a bootfs or the base image, it is going to need some files that it needs to manage. So that is what we call it as file system in a generic way. So now the kind of file system that the Docker image going to use is a union file system. Okay, and now by using this union file system, which is going to be only on a read-only way, that means when you create a Docker container which is going to contain a base image which is of the type union file system, this is a read only. That means you cannot modify anything on the operating system. Unlike your machine, if you have your own laptop or a machine, you can go and you can change many things in an operating system, right? But that things you cannot do it on this base image because it is the only a base image which is containing only the bootfs. Nothing else is there of the complete operating system, and it is going to be a read-only file system which is of the type union file system. Okay, and if you look a little closer, what exactly this is going to be, it is nothing but a tar file. Okay, that is what it will be. So now what happens is whenever you are creating or launching or spinning up a container, okay, so what Docker will do is Docker will create that container. On the base level, it is going to put a file system, and on top of that you will be putting up all the existing applications that you want. So now when you say a container is coming up, the container will contain the basic layer as the base image of whatever operating system that you have asked, and on top of that, whatever applications that you want, everything will be put on top of one another. Whereas this will be read only, and all the other applications that you run on top of that will be read write. That means now once I have a container with the base image, on top of that, say I install Java, and then I top of that, say I install some Perl or Python. Then on top of that, I can install Git, and then I can top of that, I can install some other specific applications. Like that, whatever you do, everything will be layer to layer. Okay, so that is what your container is going to actually have. So as I was saying some time back, anything that you are doing here, it will be specific to this container, and at any point of time, if you want, you can create a copy of this. And when you create a copy of this, you are not creating a copy of the complete container, but it will be taking a copy of the base image which is going to contain all the data. So now if someone else creates a container, now rather than he using a base image which contains nothing, you can create an image which has been created from this, wherein that image will have all the data that what you have run, so that when someone else spins up or brings up a container with your base image, then they will get all the layers along with the existing layer like what you have used. So that is how you can replicate the content easily. Okay, getting it?
Yes, sir.
Yeah, Adam.
Okay, so now so far I know it's going to be completely confused. Okay, now what exactly Docker is going to contain? So an overview is what I was giving to you. So to get a little deeper, the architecture of Docker is a way wherein it's not just one tool that runs everything. So there are various components in Docker. So what and all are they? The first one is we have the core components and then the workflow components. So what is the core component? What is a workflow component? So core component is the one using which we will be running Docker, and workflow components are the one through which we will be doing a desired task. Okay. So the first and important thing what we need to know is a Docker daemon. So a Docker daemon is nothing but a process through which you will be able to access and work on Docker. That means whenever you install Docker, so what happens is internally it will be having a daemon, or it will be having a process which will be running on the backend, and this is the one which we will be trying to connect. So whenever on any machine, if I run Docker or if I want to connect to Docker, we will be using some application, right? That application is what we call it as the daemon. Okay, but what we are going to do is we are not going to directly interact with daemon. So I will be running some specific commands to do it. So that command through which we will be getting everything done is what we call it as Docker client. So literally what it means is, so on my machine, if I enter a command called Docker, and if I want to do something, the command that I am entering, that is Docker, is called as the client. Whereas that client will interact with the daemon and it will get everything done. So whenever you install Docker, you are actually installing this daemon. That is what on the back end it will be running. And on the front end, we will be using some commands like Docker. So that is nothing but the client using which we will be giving the command, we will be giving some options, whatever that we do, right? That is nothing but the Docker client, which is going to interact with the daemon. So internally, these are the two components which will actually be running on every machine. So if you say Docker is running, no, it is not Docker, but there is a daemon for Docker which is running. And all the commands that you enter is called as the client, through which we will be getting some particular functionality like creating a container, stopping a container, or whatever you do. That commands that you invoke is through the Docker client. Okay. Then now coming with the next thing. So as I said, the next things what you will be doing is once you have the Docker installed, you will be running certain things. So that is when we create a Docker container. So what is the container? So container is nothing but the box, or it is the one which is going to help us to have a separate machine. Now inside the container, you will be having the images, and then you will be having all the applications that you want running in this container, and this will be running on top of this daemon. Okay, so container is the one through which you will be able to run your application specific to a operating system that you want. So as we just sometimes saw, every container will contain an image that is called as a Docker image. So that is going to contain the actual environment, that is what operating system that you want, and also what are the specific applications that you want to run on that. So like that, the image is the one that is going to run everything, and this is going to present inside the container. Okay, so these four are the important components of Docker which we will be working day to day. Now, in addition to this, we also have something called as registry. Now, what is this registry used for? So if you see the image that we need for a Docker container, right? So it is not a regular operating system image that you will be using to install operating system. In fact, if you are going to install a new operating system, or you are going to install a virtual machines operating system, you need a image of an operating system through which you will be installing it on a machine. But here for Docker, as I said, you will not be containing everything in it. It is going to contain only the base bootfs, right? So in that perspective, we need to have a specific kind of image for Docker. So how are you going to get it? How are you going to store it? All those things is what we will be doing it using this Docker registry, or it is a place where you can get all the Docker images. And not only that, as I said, if you have a container and if you want to share it with others, you can create an image based on your container, and that can be used by someone else. So like that, other than the base image, if we are creating our own images based on a container, then that is also going to be stored in this place. So Docker registry is nothing but a repository where you can store all the images and you can use it. So that could be the default images which the Docker is going to give, or it is the image that we are creating for our purpose. Okay, so that is the need of Docker registry. Now, along with this, there might be some cases wherein you want to create your own image from the scratch. So one of the way that I said is either you can use a image, a standard image which Docker gives, or you can create an image from an existing container. That is one way. Or say that I want to have an image with some specific instructions. So I want to create my own image from the scratch in a different way. So in that case, we have a concept called Dockerfile, using which you can create your own image. Okay, so we'll be going into all these things deeper, but this is just for your understanding to know what is it, because when we are starting the practicals later, you shouldn't be confused. So to mainly run, so say now when I install Docker on my machine, actually I'm going to install this daemon which will be running. Then I will be using some command through which I'll get some task done. So that command, that whatever that we are going to run, is called as the client. And whenever you are running the Docker command, that is the client, so you are going to create a container through which you will have a specific machine and do some task. And in that, the container is the one that is going to contain everything. And inside the container, you will have the image. And on top of the image, you will be putting your specific applications. Okay. And for every image that you are going to use or you are going to create, you need a Docker registry, which is nothing but a repository where you are going to store. Okay, and additionally, anything that you want to create the image from scratch based on your own requirement, then we will use this concept called container to create them.